Okay, let me go through the notes for 3.4, 3.5, part 2 in this video. So this little box up top is probably one of the most important part of the notes. So let me just refresh your memory. If you have the difference of two squares, and that's this, okay, a squared minus b squared is the difference of two squares. If you factor that, you get this. So that means if you see these factors, after you see this combo many times in a row, instead of doing the whole FOIL, where you end up having minus BA plus BA and they cancel, you can go right to this. That's going to be very, very important when multiplying factors in this section. So it's all about the factors. So facts about polynomial equations are going to help us. Okay, this talks about if x equals c is a root of a polynomial, then x minus c is a factor. Okay, likewise, if x minus c is a factor, then x equals c is a root. So how did I get my root? I set my factor equal to 0 and solved for x. All right, so don't confuse the term factor and root. They mean two different things. Be able to always know what it is we're speaking about if we ask you to give us a factor or a root. They're not one and the same, and they're not interchangeable. Okay, facts about polynomial equations. Each polynomial equation has the same number of complex roots as the degree of the function. Okay, complex roots are a combination of real and imaginary roots. So when you look at a graph and you see it crosses the x-axis in 3 places, you are seeing the real roots. You may not be seeing some imaginary roots, which don't cross the x-axis. And they will always come in pairs, by the way. Okay, so let's go and look at this. Okay, for example, when I look at this polynomial, which is not written in standard form, by the way. If it was, you'd have 4x cubed in front. So here is a non-standard form of a polynomial. I look for the highest power, and it has 3 roots. Now, that means it has 3 real and imaginary roots. I may not see all those roots, so keep that in mind as we go forward. Okay, so here we're only going to talk about polynomials that have real coefficients so far. So just to remember, complex conjugates theorem, this is important. Imaginary roots will appear in pairs, and we call these pairs conjugates. Okay, con means with, so with each other. So here's a plus bi, its conjugate is identical except for the operation right here. So if I give you this is a root, then another root is also going to be 3 minus 2i. So then I go in to say, okay, what factors of polynomials are associated with these roots? So this is it, x minus 3 plus 2i, and then also x minus 3 minus 2i. Okay, so this form right here is your first step, but it should not be your only step. You should then distribute this negative here and here, distribute this negative here and here. That gives me x minus 3 minus 2i and x minus 3 plus 2i. And you're probably thinking, well, that makes it worse. But actually, it makes it better because now I can view this as possible, the difference of two squares once I multiply them together. So look, this is your A, this is your B. This is your A, this is your B. So it's A minus B, A plus B, which are the factors that we get before we do the FOIL and get the difference of two squares. So instead of going through all of these steps, when you FOIL this, what you should say is, I'm recognizing it as a difference of two squares, so therefore, this term squared minus this term squared is my final answer, and I don't stress about it. That's going to be really important. Okay, this is a critical point that's going to make your life much better. Okay, so same thing. Look at your irrational roots. Irrational roots also appear in these pairings. Now, irrational just means you have a radical. Okay, it's not a terrible thing. It's just a radical, but you've got to contend with it. So, for example, because they come in pairs, if I have one root, and I would get this by using the quadratic formula in factoring, if I had this root, I'd also have this root. Well, how do I write those? Well, I write them like this. Okay, x minus the root, x minus the root. Okay, that's how we write our roots. But this form right here on this line is not very helpful, but it's the first step. So you're going to distribute the negative, and you're going to get this times this. Once again, view this as the difference of two squares. That's what's coming at you when you distribute this and do your FOIL. So instead of going through all the steps of FOIL, jump ahead, skip a step. Square this, subtract, square this, and you're done. And that's going to help you write these factored forms in standard forms, which is going to be essential. Okay, so when we create a polynomial equation from its roots, and when I mean create, I mean put it back into standard form. Let me just make this a little smaller so we can see all the steps. You can start here, okay, start here, factor, and then get me the zeros. Or you can start with the zeros, put those as factors, and remember this is x minus a minus 5, and that's why it's x plus 5, by the way. And then you're going to FOIL, this is not the difference of perfect squares, and you're going to FOIL and get this. Okay, so you can think of it either way. In any event, you should be able to seamlessly move from the zeros to the standard form. And the intermediary piece is going into the factored form. Okay, so let's see what this box says. Considering given roots, determine any implied roots. Okay, so these are all the things that you're going to be considering. So you're going to consider the given roots. You can generate all your factors for the zeros. Don't forget, you're going to incorporate multiplicities of greater than 1 when appropriate. That means that maybe you're going to square something. Check that the number of factors and the multiplicity of each are consistent with the degree of the polynomial. Expand the polynomial to standard form, and then whenever you have any kind of irrational roots or imaginary roots, you are going to use the difference of two squares to make expansion easier every single time. Okay, so let's start off with something somewhat simple. So let's look at this. The first one says, find a cubic of degree 3, so therefore cubics are always degree 3, with zeros -3 and 2 with a multiplicity of 2. Okay, now in this case, I'm giving you the graph so that it will go along with your understanding. But in a testing environment, or even in a homework environment, you're not going to have the graph. Okay, so let's start building our polynomial. So it's y equals, or f of x equals if you like. Take your first root, and to get your factor, you're going to say x minus the first root. So x minus a -3 is an x plus 3. Take your next factor and subtract the root. That's x minus 2. Now, look at how this hits the x-axis. That is going to be a double root in this case. It's going to be an even root in all cases. So I'm going to square this. When I square this, now look what you have. You have this times this. Do not take this squared and distribute it here and here. That is not how you square things. If you do that, you're going to drop out your middle term, which is right here. So we have x plus 3, and then times this. I would suggest doing this first. You have this now. Now distribute. So x times x squared gives me x cubed. X times -4x gives me -4x. x times 4 gives me positive 4x. Then start here. 3 times x squared gives me 3x squared. 3 times negative 4x gives me negative 12x. And 3 times 4 gives me 12, which is also, by the way, your y-intercept, which I can see right here. Okay, so remember, when you're in standard form, which is going to be this final form once I combine like terms, you can see your y-intercept. When you are in factored form, you can see your roots once you set the factors equal to 0. Each form gives you a gift. Okay, so I'm going to do, I did this just in a straight line. Many times what I'll do instead is I'll do the first multiplication of x times the whole right brackets. Then when I do this, I'll put it underneath the appropriate spot. So I think I do that later on. So anyway, when you combine like terms, you should be getting this. And let me just look and make sure that I've done everything correct, and it looks all good to me. Okay, so let's continue. That was our first example. Here's another example. Now, look at this. If I give you the graph, does this help you find any roots? No, because look, it's not touching. If it doesn't touch, it means that you have an imaginary root. Not one you get from the quadratic formula, but one with I. And let me just restate that. You can get it from the quadratic formula, but it doesn't have a radical. It has an I. Okay, so I would have to give you this information, okay? Find a quadratic function where 1, 0 is 2 plus I. Okay, if 1, 0 is 2 plus I, what's the other one that come in pairs? The other one is 2 minus I. So once again, start off x minus each of the roots, okay? X minus each of the zeros, if you will. Don't leave it there. Distribute that negative. You have these 3 terms. Identify these factors as giving you the difference of perfect squares. So these are the factors of perfect squares. So multiply x minus 2 times x minus 2. That's going to be x minus 2 squared minus, right, minus I squared. Okay, so take this term and multiply it out using FOIL. You will get 3 terms. So I did not distribute that 2 to the 2 terms inside. I FOILed it. Then subtract, what is I squared? That is radical negative 1 squared, which is negative 1. So that's always going to flip this sign, by the way. That should be your takeaway. This is plus 1. That makes this 5. And this is my final standard form of the quadratic. Okay, and over here, I did this right here is done out right here. Okay, so this is your answer, not x squared plus 4, because these are not the factors of a difference of perfect squares, because both signs are the same. So just take good note of that. Okay, so that brings us to this. This says find the quartic. So your tip-off is, it is going to be the power of 4. When the day is done, it should be the power of 4. And I'm going to fix one thing there. Okay, so things that I'm noticing. I do see a root. That's this root of negative 3. So I'm going to do this one first, x minus a minus 3, and then look at its format. It's a double root, so I put a 2. And then this is x minus 2i, x plus 2i, because that is your root. Okay, so here, we don't have to worry about any extra parentheses in here, because your 0 is negative 2i and not a constant minus 2i. So this is a little bit less complicated than our other example. So when I FOIL this, I get this. This is the difference, the factors of the difference of perfect squares. So therefore, square the first term, subtract, square the second term. Don't forget to square the 2's. So I have 4i squared. I squared is negative 1, so that becomes 4 on the positive side of things. Distribute. So here I did do this nicely, but then I made a mistake down below, which I'll fix in a second. So this is x squared times x squared, which is x to the fourth. X squared times 6x, which is 6x cubed. X squared times 9, which is 9x squared. Now look what I did. Instead of doing it in a straight line, I'm going to help myself. 4 times x squared is 4x squared. 4 times 6x is 24x. And then 4 times 9 is 36. So now just add up your columns. 36, 24x, 13x squared, 6x cubed just comes down, so does x to the fourth. But look what I did when I brought it down. So I can't permanently fix this on the video. So I'm going to make this to the fourth and make sure you change that right now, because the second I move down, it's going to change, okay? It's going to go away. So make that correction. I just brought it down incorrectly, okay? Okay, so let's keep going. So let me turn this off. Okay, so you made that correction. We're going to head down. Okay, so now they say, notice, we've bridged you away from pictures. There's no picture. It says find a quartic, that's the fourth degree function, with zeros 1 minus radical 2 and 1. Okay, it has to be fourth degree. They have to give you all the information. You can't make up another zero. So therefore, this root of 1 must be a double root, because otherwise I'm not going to get 4 roots. So I have x minus 1 and I square it. Then I do x minus each root, right? Okay, so I'm set to go. So I have bridged from this step to this step, as I have every time, by distributing the negative. Then I'm highlighting still, because this is my difference of perfect squares factors. So go ahead and FOIL this. You get a middle term. You do not get a middle term here. Square this minus square this. Radical 2 squared is just a plain old 2. You've got to expand this. This is not a difference of perfect squares, so you're going to FOIL it, and you're going to have a middle term. Then you're going to combine the 1 and the negative 2, and now you have this nice step. Okay, so now you're going to say x squared times the entire function. You get this row here. Then you're going to say negative 2x times this entire thing, and you get this row right here. Then you get 1 times this entire thing, and you get that row right there. Add up your columns. This will keep everything straight for you. Okay, these two cancel. That is canceling as well. So then you have a negative 1. This is your final answer. That's your quartic. You know it's a quartic because it has a power of 4, so it's consistent with what they told me I was going to find. Okay, I believe we only have one more. This should be it. Is that true? Let me just check. Yes, it is true. Okay, so let me slide up again. Okay, so here's the last one, and it is a busy one, but you can do this now. So I have to find a cubic. Cubic tells me it's going to be a power of 3. So I have this root, which I say x minus a minus 1, which is x plus 1, and then x minus each of these roots. Okay, so then distribute that negative. You get this, and I'm still highlighting that these are the factors of a difference of perfect squares because the signs are opposite. In order to do the math of this, I'm going to do a shortened FOIL, square the first yellow, minus square the second one. Now when you square this, remember you've got to square the I, that's I squared, which will be a negative 1 in just a second. And when you square a radical 3, the radical goes away and you get a plain old 3. Now, this negative I squared is going to be a negative 1. So it's going to be negative 3, thus the positive 3 down here. Okay, same idea. Take your x plus 1, multiply it by this term in here. Well, actually, I combined 4 and 3 and got 7, so this is where I'm going to be multiplying. So x times this entire thing gives me this row right here. 1 times this entire thing just requires me to rewrite that row there. Do your columns, and you are all set. So this is how you go from zeros to factors to standard form of a polynomial. Okay? So if you only watched me and copied, you probably haven't thought about this. So you're going to have to, do this yourself in order to really hone in your skills of moving between all the different steps. Okay? And that's what the homework is.